In this audiovisual, we will take a look at what makes triangles similar. For the triangles, if we can show that every side of one may be paired with a side of the other with a constant multiplier or divisor, then they are similar. We will take each side of one triangle, pair it with the other, and see what happens in terms of the ratio of the sides. If we do the same with another, or we can do the same with another two sides, one of the first triangle and one in the second triangle, then if the way that they are related is the same, meaning that when we divide the side of the second by the first, then the second by the first, and then if we continue to do that for all of the sides of both triangles, and we can show that when we divide one by the other, or the other way around, divide the other by the one, then the figure is going to be the same. The ratio is going to be the same in every single case. There's a constant multiplier. Therefore, if we multiply 7 by 1.5, we get 10.5. If we multiply 5 by 1.5, we get 7.5. If we multiply 4.5 by 1.5, we get 6. If we can do that for every single side of both triangles, then the two triangles are similar. No matter what the triangles look like, if the sides can be matched in that way, then they are similar. It will mean that one triangle is merely a reduction of the other, or one triangle, we may say, is an enlargement of the other. They are similar. We are taking a look at another set of requirements. For two triangles, if all of the angles of one are repeated in the other, then they are similar. We see that in one triangle we have a 75 degrees angle, in the other we have a 75 degrees angle. We are not done yet. We also show that in one triangle there's a 45 degrees angle, in the other there's a 45 degrees angle. Maybe we need to show that it will be the same for the other two angles. Although the statement said all, we need only to show that two of the angles in one are repeated in the other. So although all of the angles in one should be repeated in the other, we need only to show that two angles in one are repeated in the other. Why is that so? That is the reason. That is the reason. The reason is because if we subtract the two known angles from 180, then the other angle is known. And the same is true for the other triangle. And if we have the same two angles in one triangle that we have in the other, then the other angle will automatically be the same. So we'll see that this remaining angle is 60 degrees in this case and is 60 degrees in the other. This is because if we have two angles of a triangle, then we may determine the size of the third one. Since the two known angles have their match, then the third angle will automatically match. For two triangles, if all of the angles of one are repeated in the other, then they are similar. However, we only need to show that two are repeated. And that's all. If the triangle is right angled, then we need only to focus on one pair of acute angles, since the size of the right angle is already known to be 90 degrees. Now on the previous slide, if we can show that two angles have their images in the other triangle, then they are similar because the other one will automatically match. Now in this case, we have a right angle triangle. As a matter of fact, we have two right angled triangles. Because the triangles are already right angled, then we know that the right angle is already known, and it is 90 degrees. Therefore, we just need to focus on one more angle. And of course, you know that the other two angles will be acute angles. Now we have a 30 degrees angle there. Since those two angles are equal, then we know that the triangles are similar. The 90 degrees is already known, and the two 30 degrees angle are already known. So, if an acute angle in one has a match in the other, then the other acute angle will automatically match. Well, we don't need to go around in circles to determine that, because we see very clearly that if we take the other two angles from 180 degrees, then the final angle is 60, and there is no doubt that the same will be true in the other right angle triangle. All three angles will therefore have their equal in both triangles. For a right angled triangle, if an acute angle in one is equal to one acute angle in the other, then the triangles are similar. Now this one is our favorite. If two triangles have a constant ratio by which corresponding sides are related, and one pair of equal corresponding angles, then they are similar. We have this relationship between sides established before, so this is not going to be cumbersome for us. We take one side of one triangle, divide it by a side of the other. We have the answer there to be 2. And if we can do that again, the triangles will not necessarily be similar, but we are on our way. The first condition is established, that there's a constant ratio with the sides of one triangle and the sides of the other. 2 in each case, so we are sure of that condition. The sides met their requirement. Take a look at the angles. Notice that we just randomly throw in 2 angles. No, we did not, but it will appear as if that's the case. The angles are equal, but do they correspond? Now that's a serious question, because when the first condition is met and we need equal angles, we cannot just choose any 2 angles. The angles must be corresponding angles of the triangles. So are they actually corresponding angles? We see here that they actually correspond. And why do we say that they actually correspond? Because in the first triangle, the angle that we are talking about is formed by the 2 sides under consideration or investigation. So the 2 sides that we used in our demonstration are these 2 sides, and the angle is formed by these 2 sides. In the second, it is formed by the sides that are related to those in the first. So in the second triangle, the angle is formed by the 2 sides that are related to the 2 sides in the first triangle. Therefore, we are sure that the angles correspond. And since the angles correspond and they are equal, then the 2 triangles are similar. 2 triangles are similar if there's a constant ratio that relates all sides of the first to all sides of the second. 2 triangles are similar if we can identify 2 angles in the first that are equal to 2 angles in the second. Of course, because the third angle will automatically match. 2 triangles are similar if there's a constant ratio that relates 2 sides of the first to 2 sides of the second, and we can identify one angle in the first that is equal to the, not any angle in the second, but the corresponding angle in the second. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.